NASA's newest space observatory allows scientists to peer deeper into the universe than ever before. With unmatched sensitivity in the infrared and powerful imaging capabilities, the James Webb Space Telescope has once again pushed the boundaries of human knowledge about space. In one of its latest and most mysterious observations, the telescope captured a series of galaxies whose behavior challenges our current understanding of physics and cosmic evolution. Discovered in a distant part of the universe, nearly 13 billion light-years away, these galaxies are not only significantly larger and more developed than expected for such an early stage of the universe's existence, but also contain massive mature stars that, according to all models, should not yet exist. Before we begin, don't forget to like and subscribe to the channel for new updates. At the center of this strange discovery is the observation of surprisingly massive galaxies that formed less than 500 million years after the Big Bang. According to accepted cosmological models, the early universe should have been a chaotic mixture of elementary particles, with the tiniest protogalaxies just beginning to form. However, looking far back into the past through the fog of cosmic history, the Webb telescope has discovered giant galactic structures with complex features, spiral arms, dense clusters of stars, and enormous amounts of stellar mass. The presence of these mature structures at such an early stage contradicts almost everything astrophysicists have assumed about how matter gathered after the birth of the universe. The implications of this discovery are truly staggering. For decades, astronomers have assumed that the formation of large-scale cosmic structures occurred gradually, step by step, under the influence of a skeleton of dark matter and the slow gravitational pull of baryonic matter. The appearance of these early massive galaxies calls this theory into question. This could mean either that galaxy formation was much more efficient than previously thought, or that there was some unknown mechanism, possibly involving exotic physics, that accelerated the development of these colossal systems. Even more puzzling is the chemical composition of the stars within these galaxies. Observations made with the NIRSPEC, infrared spectrograph, and the MIRI mid-infrared instrument indicate the presence of heavy elements such as oxygen, carbon, and even iron, which in theory could not have existed in significant quantities at this stage. Such elements are usually formed in the cores of dying stars and spread throughout the universe in supernova explosions. Their presence means that at least one generation of stars has already appeared and died, which in turn indicates that star formation began much earlier than expected. This raises new questions about the speed at which the universe cooled and contracted into stars and galaxies after the Big Bang. Perhaps the so-called Dark Age of the universe, the period before the first stars ignited, was much shorter than previously thought. If stars formed and died in just a few 100 million years, the entire timeline of cosmic evolution needs to be revised. Theoretical models that previously comfortably explained the emergence of galaxies, black holes, and other structures over billions of years may now need to be radically reworked to explain such rapid early development. Even more surprising was the discovery of extremely active processes in the cores of some of these galaxies, indicating the presence of supermassive black holes. Supermassive black holes, which weigh millions to billions of times the mass of the Sun, are thought to form either through the slow accumulation of matter or through mergers with other black holes. However, data from the Webb telescope suggests that such giants were already present in the centers of these ancient galaxies. These findings contradict standard models, which are unable to explain how black holes of such enormous sizes could have formed so soon after the birth of the universe. Some galaxies also show unusual infrared signatures that could indicate either hidden star formation activity or entirely new physical processes. In some cases, their infrared luminosity significantly exceeds the values allowed for galaxies of this age and size. This could indicate hyper-efficient star formation, interactions of exotic matter, or something even more mysterious, phenomena about which modern physics cannot yet say anything definite. The energy output of these galaxies hints at violent, transformative processes. Galactic winds piercing interstellar space, stars forming in dense molecular clouds at unprecedented speeds, and possibly dark matter behaving differently than we are used to. An additional layer of mystery is associated with the spatial distribution of these early galaxies. They appear to be forming in denser clusters than existing models of the early universe allow. Such clustering could mean that structure formation began earlier and faster, or that the seeds of these structures, possibly linked to primordial quantum fluctuations, were more powerful and influential than previously thought. This discovery could have a profound impact on our theory of inflation. The idea that the universe underwent a brief but rapid period of expansion immediately after the Big Bang. If structures arose earlier and more efficiently, there may be a fundamental flaw in the current inflation model. Importantly, these oddities are not limited to one area of the sky. Multiple observations made using the Webb telescope's deep field technique, where it observes the same patch of space for hundreds of hours, have revealed similar anomalies in completely different parts of the sky. This suggests that this is not a local phenomenon, but a widespread feature of the early universe. One of the most speculative, but also attractive explanations is the hypothesis of modified gravity or early dark energy. Some theorists suggest that the fundamental forces governing the universe may have behaved differently in its infancy. Perhaps gravity was stronger then, allowing gas clouds to collapse more quickly into stars and galaxies. Or perhaps dark energy, usually associated with the accelerated expansion of the universe, played a more active role in this early period, influencing the formation of matter. If any of these assumptions prove to be correct, it could open the way to a completely new physics, perhaps even unifying quantum mechanics and general relativity into a single theory. The involvement of unknown particles or forces cannot be ruled out either. Perhaps conditions existed in the early universe that were conducive to interactions with particles that have not yet been discovered. These components could have influenced the formation of structure in ways that have not yet been detected by any experiment. Candidates include dark photons, axions, and other exotic forms of matter. If Webb's data continues to confirm this hypothesis, the telescope could play a key role not only in astronomy, but also in the future of particle physics. Another interesting interpretation is related to the idea of early universes or cosmic cycles. Some cosmological models suggest that the Big Bang is not the absolute beginning of everything, but only the last phase in an endless cycle of expansion and contraction. Within this hypothesis, certain imprints or structures can pass from one cycle to another, seeding the new universe with matter and order from the previous one. Although such ideas remain highly controversial, the discoveries of the Webb telescope give them unexpected relevance in scientific debates. On a more practical level, some researchers are revising the assumptions underlying the interpretation of the telescope's data. For example, the relationship between redshift and distance, which is used to estimate the age and distance of observed galaxies. If redshifts behave differently under certain extreme conditions, which cannot be completely ruled out, these galaxies may not be as ancient or distant as they appear. Even small adjustments to the calibration of redshifts could have a major impact on our understanding of the early universe. Nevertheless, the spectroscopic data collected by Webb remains reliable and robust, confirming that the telescope is indeed peering into an era that humanity has never seen before. Moreover, these discoveries require a rethinking of the simulations and models that astrophysicists rely on to predict galaxy formation. Models such as Illustris or Eagle, based on known laws of physics and assumptions about the behavior of matter under the influence of gravity and radiation, did not predict the early appearance of massive organized galaxies. As new data comes in, theorists are rushing to update these models or develop entirely new ones, incorporating fresh parameters and possibly taking new physics into account. The deeper Webb looks into space, the more it reveals to us a universe full of contradictions, complexity, and wonder. These discoveries are far from mere anomalies. They may be a new frontier in our understanding of how the world works. Every answer the telescope provides raises dozens of new questions. Its instruments, designed to capture the faintest glimmers of light from the first billion years of existence, reveal a face of the universe that is not only amazing, but may be beyond our imagination. This is not just a matter of adjusting models or correcting errors in data. Perhaps the Webb telescope has begun to expose cracks in the very foundations of cosmology, pushing us toward a profound and possibly revolutionary rethinking of our place in the cosmic order. The galaxies it has discovered tell of a time when the universe was still young, but already inexplicably wise, filled with structures and energies that did not obey the familiar laws. In doing so, the telescope has not simply advanced science, it has rekindled the spirit of discovery that drives it. This strange phenomenon, a glimpse of ancient, impossible galaxies blooming in the primordial darkness, reminds us that the universe is still boundless, wild, and full of mysteries. As more time and resources are devoted to studying these phenomena, and with new data coming in from the James Webb Telescope and future observatories, humanity stands on the threshold of a possible rewriting of the entire history of cosmic creation. And somewhere out there, beyond the veil of timeless stars, the answers are waiting to be found. If you enjoyed this video, please like and subscribe to our channel. Leave your comments. What do you think the Webb telescope has found? What do you think it could be? We'd love to hear your thoughts. Thanks for watching, and see you next time.